So thanks. I'm from the government. I'm here to help. So I'm Chelle Gentemann. I'm from NASA headquarters. Wait, I don't get a whoop? Microsoft? So we have a whole team at NASA headquarters actually working. It's called the Open Source Science Initiative. And we have the Transform to Open Science mission. Let's see. There we go. So I have done a lot of different stuff in my career. I'm an oceanographer, but I take a lot of pictures with different types of robots because I'm down at Jet Propulsion Laboratory a lot. I use robot sailboat vehicles to go and do cruises up in the Arctic. I led a proposed new NASA mission. And I started as an oceanographer with NASA instruments, NASA's whole suite of satellites that are looking downwards at the Earth to monitor weather and climate. And that's where my career started, mostly in Fortran and MATLAB, which is, really where a lot of science is still at. And about 2018, I went to a workshop, sort of, like this. And it was a Pangea workshop, which is an open science community that was for computational oceanography. And I was like, oh, crap. This is like a meteor type extinction event in science if I don't learn how to do this right now. So I dropped everything. I learned Python. And I immediately joined NumFocus because I saw all the libraries that I love were being supported by NumFocus. And then in 2000, just a little while later, I moved to cloud computing. I started doing this new type of science that was more inclusive. And that really changed how I approached science and how I saw a lot of the barriers, because I've always been at small institutions, at small commercial companies and nonprofits doing science outside of academia. And those barriers to doing science, to doing research are real, and it's hard to overcome. And so that's sort of why we started TOPS, is to try and break down a lot of those barriers and bring people into doing new, open, inclusive science. So I want to talk about some of these amazing scientific discoveries. So in 2016, the first gravitational waves, detecting 1.3 billion years ago when two black holes collided, and you can watch the ripples in the space-time fabric. These science, this was thousands of people collaborating together with LIGO, thousands of researchers working together to get this incredible discovery. Another discovery, you might recognize this picture, right? So this is the first image of a black hole. And this was just about a year and a half, 2 years ago. The first image of a black hole. There's Dr. Katie Bauman, and we're deeply grateful for all the open source contributors. All of their work was on GitHub in the open. This was an image I believe they was Matplotlib. Yep. And the algorithms they were using, the software that they were using, accelerated their work so that they were able to do this a couple years before. If they had to write all of that, it would have been years and years additional of effort. So another, James Webb Space Telescope. This has been in the news a lot. This is amazing discoveries are sort of coming out at this pace that's incredible. And part of that's because of the early release science program, where some of the subsets of the images are being released immediately without any embargo. And that's a little unusual. In science, a lot of times when you collect data, some people don't share it, and some people, most NASA data, you have to share. So if you're getting funded by NASA, you're required to share your data. Sometimes it's 12 months after collection, sometimes it's at publication, but you are required to share it. That's not true of all science, but James Webb has early release so that the data is available immediately. And here's an image. This is one of the first images from James Webb. And Arfon Smith wrote a really nice blog post basically talking about how the core data pipeline, the simulation tools that astronomers are using, the tools that they all use. And here's, AstroPy right here. These are the heart of these new discoveries and the innovation that JWST is going to lead to. And here's one of the results that came out just last month. This is the first carbon dioxide on an exoplanet for the first time. And you can see it in the plot right here. This is pretty incredible. And co-author Dr. Natasha Pathala is saying, NASA's open science guiding principles centered in this early release work. Because this data is available, we were able to get this result. And it wasn't just one or two people. They had a Slack group with 371 people all collaborating together. And instead of fighting over this image and trying to see who could publish it first, they worked together and they published it all together. And they published it open access. So, I mean, these are pretty amazing discoveries, right? Like, all of science has to be this awesome, right? So, if you're going to be doing science, you want to know, can we build on and extend results? All that work that science is doing, those billions of dollars that are being funded by the federal agencies to do this science, those results that the scientists are publishing, can we test them? So, Victoria Stodden tested 204 scientific papers, published in AAAS Journal Science. So basically the top journal for scientists. You know, if you want to publish a big result, that's where you go. So she took 204 papers. This is just in 2018, so it's not like 10 years ago. Can you get the data? Can you reproduce the results? 60% of the authors, even though it's required, would not get the data out. 60%. Can you, from those that you could get the data, could you reproduce the results? 74% of them, the methods that were described in the paper weren't sufficient to reproduce the results. And that's a failure. That's a failure of science. That means that we're publishing results that other people can't take and build on. Can we rapidly iterate and resolve problems? So this was actually one of the first things I worked on. I'm not that old. I'm not 1990 old, but it's 1998. So satellite data, it comes down, it's actually, it's pretty complicated to interpret. It comes down uncalibrated in these compressed files. You get the data, and then you're supposed to create a temperature or an observation, whether you're measuring wind speed or upper ocean temperature. This satellite is measuring the upper atmosphere temperature. And in 1990, scientists published a result from this newer satellite, and they put them all together and created a long time series, and they said, the upper atmosphere is cooling, therefore all global warming models are wrong. And we can't make policy about global warming. We can't try to change people's behavior because the models aren't correct, because we have the satellite data that shows the upper atmosphere is cooling, and that's against what all the global warming models are saying. So it was actually the birth of this climate denial movement. Then in 1998, they found out, we forgot about the solar wind, and there was additional friction. You could see it in the data. The satellite as it was slowing down, it was slowly going a little bit lower, just a tiny bit. And that changed the angle that it was looking at, and that changed the temperature that it was measuring.
Sorry, can you speak with the microphone, please? We don't hear.
What?
Microphone, please.
Oh, sorry. Do you want me to stay right here? Is that better? Okay. So they found this error in the analysis, and they were able to fix it. It was pretty straightforward. It was just, nobody was trying to be malicious. It was an error in the code. But because the code wasn't shared, even though the data was open, it was really difficult. Even though they found this discovery, it took an additional 5 years and a bunch of funding for them to rewrite all of this code again, and then find that, the upper atmosphere is actually warming. And the global warming models are measuring that correctly or modeling that correctly. But that's 13 years after these papers. That's delaying the response to climate change for 13 years. If that code had been open, it would have been much faster because there would have been more eyes on it. And these types of small little errors in these really complicated algorithms are really common, right? I mean, everyone knows you write a line of code, and for every one you write, there's probably 2 different ones that have errors in them, which is why open software is so important. So also, who gets to participate in science? So can anyone participate? This is access to journals worldwide. So most science is published in scientific journals still, and your citation rate is a measure of your impact on science. So the lighter colored countries have more institutions that have subscribed to the Wiley subscription service, so they get free access to journals. I was never at any of these institutions, so I ran into the paywalls that you get all the time. So often that I had a friend finally like make me an adjunct professor somewhere so that I would stop emailing him for articles. I mean, it's nice. It looks good on a resume, right? But that was because I had access and I had a friend to reach out to. Not everyone has that, and not everyone's in one of these countries that can afford these really incredibly expensive subscriptions. So what happens to the rest of the world when they just run into paywall after paywall after paywall? How do they participate in science? Is it a level playing field? You know, is science fair? We like to think that it's fair. We like to think that we aren't biased. On the left is a dual anonymous peer review analysis done by NASA, where we looked at, so non-DAPR means it's just a peer review. You get a proposal in, you put it through peer review, and NASA kept seeing that we didn't have the numbers to do people of color, but we did have just enough numbers to look at gender. So looking at gender, we kept finding that proposals by women PIs were funded at a lesser rate than those by male PIs. So there's, you know, maybe it's a younger group of people proposing who are less experienced. So maybe the proposals just aren't as good from women PIs. Or maybe there's a bias. So let's take the names off of the proposals and then put them through the panel review. And when it turns out when you take the names off of the proposals, women have a higher success rate than men. And this was repeated for several different years. So before that, we had tried everything. We showed people videos about implicit bias. We talked about biases before we did the panel reviews. We added younger people. We had more diverse review panels. Nothing changed that statistic until we took the name off of the proposal. So there is some bias, and more NASA proposals are now being reviewed this way. Is there racism in panel reviews? So you have people reviewing these proposals. So a paper just came out yesterday for looking at NSF, where it appears to be a systematic racism that's reflected in the grant allocations that's coming through the panel reviews. So it's not a level playing field, and it's something that science needs to work on. But why is it that way? So part of it is how we do science. It's the local data. So instead of using cloud-based data, is pretty new. Most federal agencies are moving there really quickly. But for a long time, part of the problem is that we were only using local data, and that's part of why it made it really hard to reproduce all of our results. You had to bring the data to you. It took, I mean, these are petabytes of data sometimes just terabytes, but it's months to download. If there's a new version, okay, start again. That discourages external collaborations, and it reinforces this institutional advantage. Again, it's much harder for someone to just decide to look at the climate in their area. It's much harder for them to do that analysis if they have to be at a big institution with these big data resources. We also, in science, there is a long tradition of closed software. Most people do not share their software, and that makes it redundant, it makes it error-prone, it impedes advancement and innovation, and again, it reinforces closed science and a closed way of doing things that make it really hard to reproduce results. You're not required to share your code. Some journals now at publication are starting to require that, but it's pretty common in most science to not share your code. There's also this local infrastructure where you're running on compiler-specific operating systems in unique environments. And again, I used to go and work in Denmark every summer so I could work on their supercomputer. You shouldn't have to fly over to get on somebody's system to use it. Though my kids really did like Copenhagen. Who doesn't like Copenhagen? Paywall publishing, again, these paywalls, these journals that are charging for people to look at federally funded science, it restricts access to knowledge, it perpetuates exclusionary practices, and it reinforces institutional privileges. And we're looking ahead at these really, really big challenges. We know that we need more we science rather than me science. We can't afford the luxury of putting ourselves first. We have to put science first. We have to put the community first. We have to put working together first. And we know also that we need more people. It is not just numbers. It's not we just need more people. We need more people with diverse points of view. We need with diverse experiences to participate. So we ask the best questions and we find the best solutions. And this isn't just let's all be a kumbaya moment. Let's be friends. There is a lot of evidence, both from business, from science. Diverse teams are more successful. Diverse teams find solutions faster. Diverse teams get better, more impactful solutions. There's so much evidence out there now that if you have a not diverse team, you're not going to get the result that you should get. It's not going to be as impactful. And so we know we need these diverse experiences. And so what can we do about this? We can move to the cloud, right? So we can have cloud-based data so that our results are reproducible, easy to access. It broadens participation because then anybody can access it, especially NASA's, and many of the federal agencies, they're putting their data on the cloud without egress fees. So it's basically public data. It's just accessible because you're bringing your compute. And there's many different ways to get on the cloud for free. I found every single one of them. Now I have a hub, but before that. Open software, we really need to move to open software. And I think all of you are the experts in this room on helping scientists move in that direction. And that's part of the reason I'm here, is sort of a plea for help and a call for action from these communities to come and work more with the scientific community so that we can learn from you and all your experiences about governance and all your experiences about open software and how you build that community. And we know it's not easy. Building community is often messy and it's often difficult and it's hard work, but it's worth it. And open software is going to speed up science. We also, the open cyber infrastructure, the science data platform. So this is an example of, this is from a paper I published called Science Storms the Cloud. And it's sort of how my workflow changed when I started working on the cloud, where I would just go through a web interface and I could be anywhere. During COVID, I got out my kid's Raspberry Pi, and on this $30 computer, I think I had 80 workers and 250 gigabytes of data running an analysis on a little $30 computer. It was, fun for me. So then you authenticate yourself, and you probably know this. You go to a Jupyter Hub, and you get all of your favorite software libraries, and then your data is right there, and you can run these analyses so quickly. And it's all reproducible and shareable because you have your code on GitHub. You send somebody a MyBinder link, and they're doing your same analysis. Also, publishing in open executable notebooks. Publishing your scientific results, especially if you're already on GitHub using Jupyter Notebooks, it makes it really easy to create just a research notebook and share this. It's executable, and it's free for anyone to look at and use and reproduce your results. So part of this is on us as a community to change how we're doing science using all of these amazing open source tools. And we know that open science is more accessible, reproducible, and inclusive. Open science, the evidence is overwhelming. It creates research that's cited more, it creates bigger impact, it increases transparency, and it generates more collaborations. And that means more collaborative projects. It's also really important that this provides access to hidden knowledge. There's a lot of knowledge in science, and you know the same thing when you start to use a new library. Sometimes the documentation isn't what you wish it is. There's a lot of hidden knowledge, and the more that we write those down and we provide that documentation for anyone, it creates more equitable systems and it increases participation. And so what does big government do well? Why is NASA moving into this space? I would be both excited and scared if I were you. NASA has this giant portfolio. There's hundreds of missions. It's not just Earth. We go to the sun. We go to exoplanets. We monitor exoplanets. We're going to other planets. We monitoring deep space, the beginnings of time. There are missions researching quantum science. Government is really good at organizing, moving slowly, and starting to fund things substantially in a way so that we provide stability. And that can be really good. And NASA now sees open source science, open source software is something that's becoming so critical to science that we can't ignore it anymore. So we have a new initiative called the Open Source Science Initiative. It's funded at $20 million per year. This initiative has 4 different elements. The first is policy. Super exciting. Sorry, Steve Crawford, if he's watching. Sorry, it's really exciting. Policy is though what allows us to do this. It's creating the ecosystem that we do science in. It's creating the rules so that people will share software, will share data. It's the cyber infrastructure and supporting the development of the open cyber platforms. So the open like Jupyter hubs and how all those science data platforms are going to evolve. We know that we can't rely on volunteer efforts anymore. So doing the infrastructure. Funding, we have a number of different funding elements that we are now supporting open source software libraries. We're supporting moving closed code to open code. We're supporting the community transformation. And we're doing outreach through the Transform to Open Science project. Some of the exciting proposed new policies are that we're changing how the requirements about data, software, and publications. And we're making these so that publishing, this is the proposed new policy that we anticipate being released within the next month, but it is not final at this time. But publishing open access with no embargo. And it's software. So remember that story that I told you about the mission software, how it took 13 years for it to get fixed because it was closed? Mission software is still closed. That hasn't changed. So this new policy says that mission software needs to be open. And mission data is going to be open with no period of exclusive access. So now those early results from those images that are released from JWST, now that's going to apply to all new missions and all their data. And the Transform to Open Science. So this is a $40 million 5-year mission to accelerate the adoption of open science. We have 3 strategic goals: to support 20,000 scientists moving to get an open science badge so that they learn about open science. To double participation by historically excluded groups across all of NASA science, and to enable 5 major breakthroughs. TOPS is across all of NASA. So it's across astro, helio, planetary, biological, physical, and earth sciences. And we're doing this through 4 different areas. We're looking at engagement, capacity sharing, which is developing open science resources, incentives. So we want to change the incentives in science so that open science activities are recognized and rewarded. And we're coordinating with other agencies. To declare 2023 NASA's Year of Open Science, where we're going to be everywhere. I'm going to get a lot of airplane points. And we're going to have high-level visibility and conferences. We're doing virtual cohorts and summer schools, and we have targeted workshops. We're going to be at all of these conferences. Really trying, there's this momentum that's happening right now. I mean, this room is filled with people who are doing open source software and open science. And this momentum is not just in the US, it's a global momentum. It's happening in Europe, it's happening in Asia. There was a big UN report that came out about 2 years ago about open science. Germany just recognized, so federally funded projects in Germany, they're recognizing software as part of their reviews. NASA will start recognizing open source activities as part of their reviews in the future. There is a momentum across agencies across the world moving towards open science, and it's all been enabled by development of open source software libraries and the people like you. And we need you, we need more of you, and we need to work more closely with you. Okay, my kids made this, and I'm trying to get them more views on YouTube. I did my own YouTube video, and I like this. They're in 7th grade. He's taking a video class. I did my YouTube video, and I got some less than kind feedback from my son. So he made this video for us to advertise our project. And I thought it was really great because to me, it seems really inspirational. And I didn't give him any directions, but he's just heard me talk about how passionate I am about changing science so it's more equitable and that more people can participate. And that's his video. I will upload these slides this afternoon to my Twitter account. I'll put a link because we do them on Zenodo, so you'll have access to all these slides. And there's a lot of different ways that you can get involved with this project. There's an email list, there's a website. We have monthly forums where we talk about different open science topics. We have a GitHub repository where discussions are enabled. And again, I'll upload these to Zenodo and put out a link to them on Twitter later today. So thank you very much. And I wanted to make sure to leave time for questions. So if you have questions, I think you can ask them and then I'll repeat them so that people online can hear. Yeah, in the back.
So if we've already got some open source code that we've been working on that I don't know that it's redundant anywhere for science, plasma science specifically, how do we get involved with POP? Do we just follow this and check out your slides? Like, how do we kind of start collaborating with you to get the code into your hands?
Well, if your code's on GitHub, it's halfway there, right?
It is.
So what you would want to do is probably reach out to different NASA science teams. And one way to do that would be to find out, so one of the requirements of the new policy, again, policy, I find it less than exciting, but it is incredibly important because this new policy is requiring all science meetings to be open. So a lot of times, if you develop software, it's really hard to know where the community is, where they're meeting. Now, all of those meetings are going to be open to the public so that they'll be advertised. You can find out about them, you can attend. And so I would join TOPS, like the email list. We have lots of notifications of different people come and speak at the monthly forums. And what I would do is try to reach out to us and we can connect you within NASA.
Thank you.
Yeah. I think in the front, yeah.
Yes, so thank you very much for the presentation. It was very interesting. So I'm all for open science and open software, and I think this is not a controversial take in this room. But at the same time, I see that it's a bit nuanced in the sense that some journals are charging like $9,000, for example, to publish a single paper. And I'm wondering how these policies can help with systemic change in academia, how citations are measured, how success is measured, and so forth, which causes all sorts of mental health crisis, right? So I would like to ask you what you think about that and how the government can help.
So right now, if you want to publish an open access article in Nature, I believe it's $12,000. Many of the journals that used to charge about $500 or $600 for publishing in them are now charging $1,800 because they're forcing you to go open access. They've now made it a requirement, and so they've more than tripled the price. And they're saying, well, but it's open because it's the government said. The government said we have to do that. So how open science actually works is very nuanced because there's been a lot of comments. So I was at a conference in La Jolla yesterday that this same question came up. And one of the big things that we've heard is for the rest of the world, if you're not funded by NASA or NSF or NIH, one of the big federal agencies, you may not be able to afford to publish any longer. So while open access sounds great, there's a lot of nuances in how it's implemented so that we actually broaden participation in science. So there's different ways to do that. There's working with the journals so that right now most journals have waivers that if you're from a certain list of countries, you can publish without paying the fee. You can also apply to not pay a fee. I think that there's also a responsibility on us, and this is where the metrics come in, and as a community, we have alternatives. We just aren't valuing them. So you can publish in an executable Jupyter book. You can get a DOI for that publication, and people can cite your work and they can reproduce it. But right now, that's not seen as valuable as a publication in Nature or Science. Our community isn't valuing it. So part of what we need to do is find out new metrics for science. And as a community, say, we want more people to participate. We want to give them recognition. And we can't have $12,000 to publish be the only way that we provide incentives. So this is this open access requirement, the Nelson memo that came, so there's a big OSDP, a White House memo that came out in August called the Nelson memo. This is asking all federally funded agencies to develop a plan so that by 2025, all of their funded projects will have open access publications built into them. So we have some time to figure this out. And so now it's been announced that this is going to be the way it is. If it's federally funded, it's going to be open access. We've got a few years to make sure that it's equitable. And there's a lot of people talking about this right now and thinking about how we're going to do that. Part of this is going to be the science community, the software community, deciding what metrics we're going to use and how we're going to value each other's work. Yeah?
Thank you so much for the insight. One of the slides you mentioned 60% that they're required to share their data, but they are not. I'm wondering what is the maybe policy or enforcement strategy that is. Is there anything really solid there, or is just it would be nice to share?
So the question was on the slide that I showed that from the Victoria Stodden paper in 2018 that 60% of the people weren't sharing their data. And the question was, well, they said they were going to share, is there any enforcement mechanism? So most federally funded research is funded through grants, which are considered a gift to the public good. So no. Now you have to, so the journals, when they're publishing, they are agreeing that they will share their data. But if they don't, there's no enforcement mechanism. Now what's happening is in the review process, papers won't get published until, so many of the journals are shifting this now because of this paper, because of these results where people said, just contact the author, and then the author would never respond to your email. Okay. And there could be many reasons for that, but yeah, so many of the professors weren't responding to emails. So now many journals are requiring you to have your data in a repository and have it be public before they will publish your paper. And it's okay during the review process for some of these journals to say, here it's all set up. It's not going to be public until this is accepted. But many journals now do require that as a condition for publication. Many of the agencies now are moving towards these open data requirements where you have to have a data management plan. You have to document and say exactly when, how, and where you're going to release your data and make it public. So it's moving in a direction of enforcement. Through the publication is the main way of enforcing it. Because the federally funded grants, it's difficult to enforce unless, if you're going to go up for another grant, the grant officer might look back and see whether or not you did what you said on the other grant. So, yeah?
Yeah. Hi. Sorry, I'm from a biotech company, so I think from a work standpoint, I'm just curious, are you guys doing coordination with BARDA for this initiative? Because that would be obviously great for us since we're FDA. And then I think second, we're coming right out of an election here. There's always this sort of idea that like a little knowledge is a dangerous thing, and I'm thinking about how like that for scientists who did the black hole photograph, who got harassed because people were like, oh, lines of code count is up. So I'm curious how that sort of education and how kind of resistance to the fact that again a few factoids can be decentralized.
Yeah, so the question was about coordination with other federal agencies, and while being open also led to the harassment of Dr. Katie Bauman. And so first, yes, we are coordinating with other federal agencies, and I would anticipate an announcement in January about the specific agencies. I believe in the first 2 weeks of the year. And again, there is a momentum across all of the federal agencies to move towards open science. And with regards to the harassment of Dr. Katie Bauman, that was really, really hard to see, I think, for all of us, because one of the things that I remember reading was people went through the GitHub repository and they counted the lines that she had committed, and then her other colleagues had to step up and say, no, she's cloned this repository, and then she contributed it. Yeah. Sometimes it's hard to be a woman in science. I would say that, unfortunately, That is not the exception for women in science. I think that the barriers are very real, and they often, unfortunately, usually they come out in private in smaller meetings. Katie had a very public way to, it came out very publicly, but that's those same biases and discrimination and harassment, both towards women and I think people of color, are very, very real, and you can see them in those panel reviews. One more question. Yeah.
Hi, I'm curious. The open data is obviously great, and it's great to ask people to put their code out there. But coming from academia and working in research groups, people are often not, their primary expertise is in their domain field, and they write code that hopefully doesn't have errors in it.
It does.
And then if they're asked to share it or publish it, a lot of times what goes out is something that can't be run anywhere other than their machine, even if they're using 100% open source tools. Is there any work or policy towards increasing either availability of research software engineers in academia or training for students, PIs, to actually put out code that then can be used by other people?
So part of TOPS is this, we're starting with open science training, and we're also looking to provide additional science training. We recognize that there are a lot of tools in science, not just computational tools, but also in management and like developing kind and inclusive environments that there's no class on running a meeting in graduate school, just like the only programming class I had was Lisp in like 1992. So yeah, we are working to provide additional resources. I think that what's changing though is that rather than asking people to spend a lot of time becoming really skilled in an area that they're maybe not trained in or not that comfortable in, what's changed is that the open source tools have actually made it so much easier to do reproducible science that you don't have to become an expert, that if you can just use Docker, or if you understand how to use, if you're on a science platform where, you've created an environment file, those things are making it more reproducible. And we also need to recognize that we don't maybe need to reproduce or have everything be executable. That simply releasing your software is actually really valuable, even with all of its, lack of documentation, lack of comments. The variable names are like X, X1, X1A, X2. And I know because we just gave some of my code to some students to redo, and they were like, what the heck? It was a test. But even that is super valuable, right? It's because it's a record of what went into a publication and what into a result. And although you would love for it to be commented and well-written and executable, even just having that code is a step forward. So, and it is effort to make it executable. So maybe the first time you publish it, nobody, maybe only one other student is using it. But then if it does become a more important piece of software, then that's the time maybe to invest more effort in commenting your code and making it executable. So thank you. Thank you, everyone. It was really nice to be here.